You've probably tried this at least once in your life. You reached over, tried to tickle yourself, and felt nothing. Maybe you tried faster, maybe you tried different spots. Still nothing, it just doesn't work. But here's the thing, it's not that you're doing it wrong. Your brain is literally stopping you from feeling it. And today we're going to find out exactly why. Let's start with what actually happens when someone tickles you. When another person touches the soles of your feet or your sides, your skin sends rapid signals to your brain. These signals travel through nerve fibers called C-tactile afferents. They're special fibers that respond to light, gentle touch. They fire the most when the touch is slow and unpredictable. That unpredictability is the key to the whole thing. Your brain processes the touch and goes, "Wait, what is this?" That surprise triggers a motor response. You laugh, you squirm, you pull away. That's the tickle reflex. Now here's where it gets interesting. There's a part of your brain called the cerebellum. It sits at the back of your head, right above your neck. Its job is to predict the consequences of your own movements. When you reach out to touch something, the cerebellum already knows what's coming. It sends a copy of the movement signal to the rest of the brain before your hand even makes contact. This is called an efference copy. Think of it like a preview of your own action. The brain uses this preview to cancel out the sensory response. So when you try to tickle yourself, the cerebellum says, "Yep, I know this is coming," and it dampens the signal. The somatosensory cortex, which is where you actually feel touch, gets a reduced signal. And reduced signal means reduced sensation. No surprise, no tickle, no fun. There was actually a study where scientists used fMRI scans to watch the brain during tickling. They found that the cerebellum was highly active when people tried to tickle themselves. But the somatosensory cortex showed much less activation compared to when someone else did the tickling. This confirmed that the brain really is suppressing the sensation in real time. It's not imagination, it's not weakness, it's hardwired into your nervous system. Now here's something wild. People with certain types of schizophrenia can actually tickle themselves. Scientists think this is because their brains have difficulty distinguishing between self-generated actions and external actions. The efference copy mechanism doesn't work the same way. So their brain can't predict their own touch the way a healthy brain does. This means the surprise element is still there, even when they do it themselves. It's one of the clearest examples of how tickling is really about prediction, not about touch. So why did we evolve this system in the first place? Tickling probably served an important social function. In young animals and babies, tickling and playful touch helps build social bonds. It teaches the brain to distinguish between friendly touch and threatening touch. By suppressing self-tickling, the brain forces you to rely on social interaction for that sensation. It's essentially a mechanism that says you need other people to feel this. Want to test this yourself? Try this, close your eyes and have someone else tickle your foot. You'll feel it immediately. Now try the same thing yourself, same speed, same pressure. Almost nothing. The only way to get a slight effect is to distract your brain. Some people can get a mild tickle by doing it in a mirror or by having someone else guide your hand. But even then, your brain knows it's your hand doing the work. So the sensation is always weaker than when someone else does it. So next time you think about why you can't tickle yourself, remember this. It's not about the touch, it's about the surprise. Your cerebellum is predicting your movements before they happen. And without that surprise, there's no tickle. It's your brain's way of saying, "I already know what you're about to do."